Everything you have ever known, every atom, every flicker of light, every moment in the tapestry of time, emerge, scientists tell us, from a mind-bending burst we call the Big Bang. In a fraction of a second, a universe unfurled. Galaxies took form, physics unfolded its rules, and the story of all existence began. But as we marvel at the enormity of what came after, a quieter, deeper question echoes. What happened before? What existed, if anything, before reality itself was forged? Back before the dawn of time? Is it even meaningful to ask such a thing? Tonight, we do not journey through space. We traverse the edge of knowledge, standing on the precipice where science, philosophy, and imagination entwine. The question of before the Big Bang is not merely a curiosity. It is a search for the deep structure of our reality, a confrontation with the boundaries of what might be knowable and perhaps what forever lies beyond. Let's begin by facing the question head-on. What does it mean to speak of a before at all, when time itself was born in the Big Bang? Our everyday intuitions cannot help but rebel. Causes must have effects. Every flame must have a spark, and every event, a before and after. Yet the very laws underlying our universe challenge this assumption. According to Einstein's general relativity, space and time are not merely the arena in which events unfold, they are themselves dynamic, flexible, shaped by energy and matter. Go far enough back in cosmic history, and you'll reach a singularity, a point where not just matter, but the very fabric of time and space seems to cease. Stephen Hawking once likened asking what came before the Big Bang to demanding what's north of the North Pole. The question, he said, is simply meaningless, because there is no before, just as there are no directions north of the place where north ends. So, are we wrestling with a paradox, born from the limits of our human language and thinking? Perhaps. For millennia, our minds have been tuned to think in terms of time, causality, and beginnings. But when it comes to the birth of the universe, these very tools may fail us. Our words fracture around concepts too vast, too subtle for vocabulary or even logic. Yet still, the question draws us. If not a before in time, could there be a precursor of some other kind, an origin lurking beyond what we can conceive? Let us turn to the world of quantum physics. The deepest, most fundamental description of reality science has achieved. Here, the plenum of existence is not simply empty. Even a perfect vacuum, stripped of all matter, is a frenzy of activity at the tiniest scales. Quantum mechanics shows us the so-called vacuum is no static void. It is a seething ocean of possibility where uncertainty rules supreme. At these heart-stoppingly small distances, the uncertainty principle allows virtual particles to blink into existence, borrow energy from nothing, and then vanish again in the blink of a cosmic eye. The foam-like structure of this arena, called quantum foam, suggests a universe where something can, in a sense, emerge from nothing. Might this quantum froth, eternally in flux, be the ground from which the universe sprang? Some physicists propose that an utterly empty nothing is unstable. Owing to the uncertainty principle, even nothing in the quantum sense is brimming with potential. Edward Tryon once quipped that our universe is simply one of those things which happens from time to time, a quantum fluctuation turned colossally real. In models of quantum cosmology, universes may be born out of tiny, spontaneous fluctuations in this foam, each inflating out of nothing into its own cosmos. If true, then perhaps our universe's creation was not a unique, privileged event, but one of countless possible sparks in a grand, pyrotechnic display of creation. Yet, the mystery only deepens. If the universe could pop into being from quantum nothingness, what stands behind that quantum realm itself? Does the question simply ride itself further and further into the depths, each answer unearthing yet more profound uncertainties? Some cosmologists, seeking to widen the lens, propose a cosmos not bound to a single birth nor a single end. Consider the theory of eternal inflation, a radical expansion of our picture of reality. In this model, the space we inhabit is just one bubble in an eternally frothing sea of inflating space-time, where the process of creation is ongoing, not singular. Imagine a boundless, effervescent field, what physicists call the inflaton, constantly expanding, faster than light. Within this field, regions may randomly decay into stable, lower energy states, spawning new bubble universes. Each bubble pinches off and becomes its own domain, perhaps with its own unique fundamental constants, even its own laws of physics. Our entire observable universe is merely one bubble among an infinity of others, like a single soap bubble adrift in an unthinkably vast foam. In such a multiverse, there is no grand beginning, no final end, just a ceaseless churning of emergence, an endless bloom of universes. If so, the question of what happened before the Big Bang dissolves. The Bang was not the beginning, but a local event within a much older, larger, possibly eternal process. If eternal inflation is right, then the story stretches long before our little bubble and will continue long after, the cycles endlessly and fruitfully repeating. But perhaps eternity and infinity have other shapes. Across human history, and increasingly in cosmological theories, cyclic patterns of creation and destruction recur. The ancient mythologies of India, for example, envisioned an eternal universe composed of endless cycles: creation, maintenance, dissolution, and then rebirth, a cosmic wheel spinning without beginning or end. Today, a modern scientific cousin to this vision takes the form of the cyclic, or Big Bounce universe. In these models, the universe may not have arisen in a unique Big Bang, but from the collapse of a previous universe, a bounce, not a beginning. Just as a ball bounces when it strikes the ground, the totality of space and time may contract under gravity's pull, compressing inexorably until densities soar, then rebound in a new expansion event. Gravity, quantum effects, and the properties of exotic forms of matter or energy might all contribute to averting a true singularity, a place of infinite density. Instead, the final crunch is followed by a new, roaring birth. In such a scenario, not only does before make sense, the entire cosmos has a past, and even potentially a future, stretching back and forward through countless cycles, erasing the need for a singular inception. Thus, the modern cyclic universe weaves together threads from the oldest philosophies and the newest physics. We begin to glimpse a cosmos, where time, matter, and space themselves pulse through infinite phases, neither created nor destroyed, but endlessly transformed, echoing ancient wisdom in equations and models of 21st century science. Yet possibly, the secret is more subtle still, structured in a realm so strange it defies even our wildest intuition. The universe, some believe, is fundamentally not made of particles, fields, or even bubbles, but of tiny vibrating strings. String theory, in its most daring versions, imagines our familiar three-dimensional world as merely the surface, a brain, as theorists call it, of a higher dimensional reality. Picture a sheet of paper floating within a larger room. Our universe could be such a sheet, only with 3 spatial dimensions. In some versions, there are multiple brains, like pages in a cosmic book, drifting within a grander, unseen space. When brains collide, the energy and distortion could trigger Big Bang-like events, violent, universe-forging outbursts. Perhaps before our familiar universe began, another brain approached, and in its collision with ours, the ignition of a new universe occurred. Under this view, the prior state is not merely emptiness or nothing, it is a landscape populated by higher dimensions, by brains and strings and forms of existence we can barely begin to picture. Our Big Bang, then, would be just one event in a grand, never-ending play of higher dimensional physics, a passing tremor in a cosmos brimming with deeper, odder structure. All of this forces us to revisit a question even more elusive. What do we really mean by nothing? In everyday life, nothing means an empty room, a blank slate, a night without stars. But in the quantum world, emptiness teems with activity. 0-point energy, the lowest possible energy state, cannot be truly zero. Virtual particles appear and disappear within any vacuum, momentarily blotting out nothingness with the spark of being. Perhaps then, existence did not erupt from a true nothingness, but from a pregnant void, dense with subtle energy and potential. The very laws that dictate the fizz of virtual particles might themselves be the preconditions for something to arise, including, perhaps, our universe. Even the concept of nothing may be an illusion conjured by our limited perspective. Perhaps the true ground for existence is something forever hidden, a domain we have not yet imagined, inaccessible to experiment and beyond language. In this view, the appearance of existence from nothing is not magic, but unfolding, like the simple blooming of a flower from a hidden root. All these scenarios, the quantum foam, eternal inflation, cyclic bounces, brains in hidden dimensions, illuminate but never fully resolve the mystery. No experiment can peer before the moment of the Big Bang. The very structure of time and information stands shrouded, lost to us. Yet the quest to know what lies beyond the edge drives us to the heights of science and the depths of philosophy. What if our universe is not fundamental at all, but a fleeting simulation, a dream within a cosmic mind, or a single paragraph in a vaster library of possible realities? What if, by asking about before, we glimpse the limits not only of our knowledge, but of our very being? The pursuit of this question, what came before the Big Bang, is deeply human. We are compelled by curiosity and wonder to ask what lies beyond the visible, to seek causes, stories, explanations. Every culture, every age has asked how all this came to be. Whether or not we ever truly answer this question, in asking it, we define ourselves. We are meaning makers, problem solvers, seekers, and storytellers. The mystery draws a horizon we may never cross, but in striving toward it, we illuminate the nature of science and knowledge itself. As we contemplate these cosmic riddles, we become aware not only of our ignorance, but of the scale of our home and the audacity of our inquiry. Even in the face of the unknown, we dare to ask, to theorize, to dream. Physics, mathematics, and the stories we tell are the torches that light our way, revealing not only the universe, but also how we choose to engage with the greatest mysteries. And so we return to our opening thought, that what existed before the Big Bang may forever remain unknown. But perhaps that is not a defeat. Perhaps the point is not the answer, but the asking. It is in striving to see the darkness beyond the edges of our world that we catch, ever so briefly, the glint of truth. We may never fully understand what came before the Big Bang. Our words and theories grasp at shadows on the wall of Plato's cave, while the reality of origins eludes us. But by peering into the abyss, we find ourselves changed. The universe becomes not a static place, but a living question, a puzzle whose solution may always be just beyond our grasp. In the act of asking what came before, we ignite the very spark of wonder that makes us truly human. And in this search, we move closer, not only to the truth, but to awe, humility, and wisdom. Let us continue together to question, to explore, to push past the boundaries of the conceivable. For in every answer, and in every mystery yet to be unraveled, we draw nearer, not only to the origins of the cosmos, but to the deepest understandings of ourselves.